Well, if you're wondering, why is it that y is proportional to the x squared, right? Well, I mentioned that when you graph y and the square root of x, I will get a straight line. Because remember the proportionality symbol here, this will give us a straight line. So maybe I can show you an example on that, like for what it means. Let me just change the graph here. So let's say a common, it's a basic one. Let's say y and then x. So let's say 0, 0. This is 1. This is 1. If this is 2, this would be, let's say 4. If I have 3, this is 9. And then let's say 4, you have 16. So if I'm going to graph this one here, let's say this data. So see what would be the relationship of this data here. So 0, 0, again, this is my x, this is my y. So it could represent any quantity. So 0, 0 would be here. And for the scaling, for the value of x, I just have 4. So 1, 2, 3, 4. So this would be 1, 2, 3, 4. And then for my y, the maximum is 16. So it must be, I should fit all of them in here in the along the y axis. So 2, 4, 6, 8, then 2, 4, 6, 8. So maybe I can use 2, 4, 6, 8, 10, 12, 14, and then 16, then 18. Okay. So for 1, it's 1. For 1, it's 1. So it's somewhere here. And then for 2, it's 4. For 3, it's 9. And for 4, it's 16. Okay. So plotting the data points, if you can see, that is not a straight line. So therefore, this is a quadratic function. Okay. So a parabola, actually half of the parabola. So we say that for this function here, y is directly proportional to the square of x, right? So, well, to show that indeed your y is directly proportional to the square of x, I can plot this one again here. Like this is just taking the square of x, right? So if I'm gonna square the x here, so that means that the value of x taking the square, so this is 0, this is 1, this is 4, this is 9, and this is 16. So again, the third column here, I'm just taking the square of x. So if you can observe what happens to my graph if I'm going to do that. So again, I'm not changing my value of y. It's the same thing. So I'll be plotting these two here. This and all of this. So same value of y, but I'm changing the value of x. So again, this is now x squared. This is y. So see what happens. This is maybe I can no longer use 1. So maybe 2, 4, 6, 8, 10, 12, 14, and then 16. Then same thing here. The minimum is 0. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So now if I'm going to plot that one again, see what happens. 0, 0. And then for 1, it's 1. For 4, it's 4. It's 4. And then for 9, it's 9. 9 is somewhere here. And then for 16, it's 16. So if you can see, generally there, that is just a straight line. Although not perfectly, because I approximated the half portion. But if you can see, this becomes a straight line. So is it not that if I'm going to represent their relationship, this is y is directly proportional to the square of x? Okay, so actually what I did here is just showing that indeed y is directly proportional. So that means that as I increase the square of x, y also increases. That is why it becomes linear. Okay, so the meaning of this one is same thing for the inverse function. That means that at first, if I'm going to graph y versus x, I'll get this graph here. But if I'm going to graph the reciprocal of x against the y, again, the same value of y, I'm just changing the value of x into 1 over x, I should get a straight line.